Amy, can you make sure recording is on? My end, I'm not able to hit that, but I want to make sure we get all this.
Yep, got it going.
Perfect, perfect. Thank you. All right.
The volume is not up?
You guys should be able to hear that.
No.
Not hearing it.
So Nathan, if you reshare your screen, there's a box you have to check off if you want to share sound. It's very easy to miss.
Got you. Thanks, Alex. I see it. That's a new option I see. I don't think it's always been like that. How's that?
Better.
Okay.
Students in Melbourne have been given an assignment which is out of this world. They are learning how to propagate basil plants that could end up on the plates of NASA astronauts at the International Space Station.
Let's speak now to Zaleka Farrugia, a Year 10 student from the Catholic Regional College, Caroline Springs.
Growing Beyond Earth is a program that specialises in plants growing beyond this earth. We are one of 2 Australian schools that are part of this program, which originated up in Florida. It strives to grow plants in order to advance our mission of space exploration, astronauts' well-being, and the planet's environment. Plants grow in a specialised chamber that mimics the conditions of the International Space Station. If successful, it can assist in plants being grown up in space rather than consistent exportation of food produce, as well as the fact that these plants have the potential of being grown on other terrestrial planets and moons. Plants grow in this specialised chamber, which has plants having to adapt to environmental changes, which kind of correlates to the problem that exists in our world today, which is climate change. The idea that plants have to adapt to environmental and temperature changes in order to grow, just like it does in the chamber, work together, and if successful, the passion and curiosity for space exploration can be much more environmentally safe, and astronauts can further gain nutritional value, mental benefits, and more from growing it up in space and potentially on the moon.
The plants that grow within the International Space Station continue to make a positive impact not only towards the astronauts, but to the wider global community. Having fresh produce on board ensures many health benefits for the astronauts, especially with its sources of proteins, minerals, and vitamins that enrich and have positive effects. Discovered from our 2 experiments, plants that we have tested have been able to thrive in these similar conditions in space. By focusing on the humidity and the temperature of our plant chamber, we have determined that coriander and sage have been able to succeed in growing in these conditions.
As this is a project undertaken here at Catholic Regional College, Caroline Springs, this also ties into what we are learning in class. In science, we learn about the experimental design. These apply to our Growing Beyond Earth project, such as how we use a few basil plants as control to work towards addressing our aim of determining how plants grow in a simulated space-like environment. Every week, we measure our plants using skills gained from both our science and math classes and ensuring we work closely together as a team as we apply our critical and creative thinking strategies. We record our data using a spreadsheet that helps us to monitor the health of the plant. Our decision-making skills are crucial in all our observations as we are continually making decisions about measurement parameters, observations, and our overall conclusions.
For these experiments, we have been meeting weekly on Wednesdays at lunchtime to record measurements relating to each of the 6 plants. We have used every other lunchtime session to water the plants and monitor the overall temperature and humidity settings of the growth chamber. Each week when we meet, we discuss the current experiment and our progress to date. We need to work together to create a smooth flowing system to ensure the experiments can reach their full potential, and then we are each across every aspect of the process. For the next experiment, we are hoping to plant Indigenous plants. Indigenous plants not only have great nutritional value, but they have great usages for medicinal purposes in creating a positive mental environment for the astronauts on the International Space Station.
Awesome. I get a chance to meet all those students, and they were very excited about the program. They just wanted to share, so I promised them that I would share this with you as well. So with that, I'd like to turn it over to Dr. Carl Lewis, the director of Fairchild and the PI on this project.
Yeah, all right. Thank you, Amy. And so glad to see that video. I know some of you teachers have created videos like this in your own schools, and I hope this inspires the rest of you to do the same. And please share those videos with us. We love them. It just really helps us publicize the program and tell everybody what it's all about. But so glad to see so many returning names that we've gotten to know over the years, and also so many new teachers joining the program. Welcome to Growing Beyond Earth. I did an in-person training for a number of schools in South Africa yesterday. So this program is really growing and expanding all over the world. We did that in-person training because it's midnight there right now. So that was a convenient way for them to get trained this year. But yeah, we've been doing this program we're going into our 9th year, and we've seen so many students, tens of thousands of students come through and get a lot of different things out of the program. We've had students that have gone on to internships at NASA. We've had many that have gone into agriculture sciences, into aerospace. But of all the students that come through, as the director of a botanic garden, I just want to make sure that these fundamental lessons about plants are absorbed by all the students. That's really the great thing about this program, is that we just want every student to understand that plants are what make it possible to live on Earth. And whether we're living on Earth or we're living someplace that's not Earth, we want to be thinking about plants, we want to be caring for plants, and we want to bring plants along with us on all of our journeys. So just get that message through to your students, and we think that's going to be a great success. And we look forward to this year. Now, we've had a lot of changes. We're so pleased to have Nathan on board, and Nathan is cranking through and doing a lot, following up on a lot of the suggestions that we've heard from so many of you over the years. In particular, working on some curriculum activities, elements and activities that will go along with Growing Beyond Earth. So we're going to be rolling those out. Those are going to be really exciting. But then other changes, you'll hear about changes in the growth medium, changes in the way we're manufacturing the kits, changes in the way we're distributing the kits and all the materials. So it's a real learning experience for all of us, but it's been really exciting over the past few months and weeks and days. So be patient with us as we roll everything out, but it's going to be good. So, all right, thank you so much, and let's get on with the training.
Awesome. Thanks so much, Carl, and Amy too. Thank you both. All right. Well, we're going to move on to, if I can get the slide to advance, we're going to move on to Trent Smith and Joya Massa from NASA. They'll set the context in the NASA perspective. So Joya, Trent.
Okay, great to be here. Great to see everyone. So do you want to continue sharing, Nathan? Are you good with that and just advancing? Or do you want me to do it?
If you want to take over the sharing, that's fine by me.
I mean, I think we're fine with you doing it. That's
okay.
That's great. So
sure.
So I'm Joya. I'm a plant scientist here at Kennedy Space Center. I'm actually not at Kennedy Space Center right now. I just drove home to be on this tonight. But my colleague Trent Smith is our research advisor here. And so, we know some of you are new, some of you have seen this before. So some of this will be a bit of a review for those who've been here before, but we tried to spice it up with a few of the new updates. So next slide, please. Mm-hmm. Yeah, so, why are we growing plants in space? There's a whole series here of photos of astronaut Mike Hopkins, who's one of our favorite astronauts because he just adores plants. But one of the main reasons that we're growing plants is, you can see in the bottom left, he has the packaged diet, the standard space station diet. This is actually the holiday diet, Thanksgiving diet. We are looking at supplementing that diet, providing fresh, nutritious, whole food, vitamins, minerals to the astronauts in the form of plants. At the same time that you're growing plants for food, they're going to provide psychological benefits to the crew. And then plants by default do things like recycling the atmosphere. Now on Earth, that's really important. That's how we're all here. That's how we're all breathing. But on a spacecraft, it becomes even more important because you're breathing out CO2. You don't have this giant, beautiful planet as a buffer. You have a small kind of tin can that you're in. And so plants can take up that CO2 and generate oxygen. Right now, we do this through a variety of physical, chemical means, but ultimately, we want to do this through biological processes like growing plants. Plants are also really important in recycling water and can be really important in future spacecraft. So if we go to the next slide, Trent's going to talk about our roadmap.
Thanks, Joya. Yeah, so, right now, all the research that we're doing on plants happens either on the ground or on the space station. And so this is why you're so important, because there are a lot of questions that we have, and the answer is not in the back of the book. We don't know the answer, and you're going to help us find those answers. And so that's our ground research there. We use the space station as our microgravity laboratory to learn how the plants might grow in microgravity. And then the things that we learn both on the ground and on space station can translate to growing plants on the moon. And then the lessons that we learn there will go into a Mars transit vehicle for the astronauts on the way to Mars and ultimately on the surface of Mars. We think that we're going to be looking at hydroponic systems or a reusable substrate for the Mars transit. Actually, it's really exciting. The Canadians, Germans, and Italians are working together on some lunar concepts and lunar agriculture test beds, and they're looking at aeroponics and hydroponics. So it's a really exciting time to be not only in the space business with all the new commercial companies and the economy that's developing around LEO, that's low Earth orbit, but also there's going to be a lunar economy. And then if you're growing plants for food, this is a really exciting time for you. And so we're so glad that you're here. Joy, what's next?
Yeah, next is our vision. So our vision is to ensure food system security on long duration missions beyond low Earth orbit. And by food security here, we mean the condition in which the crew have continuous access to sufficient safe and nutritious food, which meets both their dietary needs and food preferences in order to maintain peak health and performance. So yeah, you can click one more and then you'll get all these bullets up on the screen. So near term, we're looking at supplementing the packaged diet. We're going to be still doing mostly, physical, chemical life support, but we'll be eating that stowed food and the packaged diet. Long term, we're moving in that direction of Earth independence. So we're starting to include plants more and more as we go farther and stay longer. So if we go to the next slide, we'll talk about some of the plants. And I think many of you have seen this slide before. We keep updating it a little bit, but we're looking right now at the left-hand side of this slide. We're focusing on our salad crops. We're focusing on herbs, things that you can eat fresh and add to that packaged diet. Microgreens has been something that we've done a lot of work on at Kennedy. And we think there's a lot of potential for them. But we have worked in the past on staple crops, and we've gotten, a lot of research, decades of research on crops like potatoes, sweet potato, and wheat. They're just going to require more equipment. You're going to have your cooking equipment and your food processing equipment, and they're going to require robotics and automation because, astronauts aren't going to have time to thresh the wheat, mill the wheat, grind it into flour and then, bake bread and everything with it every day. So you're going to have your bread machines and all of your equipment and also robots probably to do a lot of this work when we're on Mars. So if we go to the next slide, Trent, you may talk about the space environment a bit.
Yeah, you bet. So when we grow the plants in microgravity, things are very different. You may have seen how the astronauts, when they play with the water, it forms the ball like you see there in the bottom left. And what you see in that picture is actually a sphere of water because inside there's an air bubble. And so when we water our plants on Earth, right, you pour the water onto the soil, the water drains down and actually pulls the air along with it. And so that aerates the soil and it provides oxygen to the roots. When we water our plants in space, it's very different. It's very difficult. It's hard to get the oxygen into the water. And it's probably our biggest challenge is watering plants in space, just because of the way water behaves in microgravity. And it gets even more difficult when we move away from using arsenite and soil substrates or granular media to hydroponics or even peat, long fiber peat systems. So it's going to be challenging to start reusing the substrate over and over, which is what we're endeavoring to do. There is no convection in microgravity, meaning that if I boil water in microgravity, the bubbles do not rise. They just stay right there and go right to the middle. A hot air balloon does not rise, it just stays there. And so what that means is if I take a nap on space station and there are no fans, I end up with a bubble of CO2 around my head because it's all just diffusion. And I will be a very unhappy astronaut. If I'm a plant, I end up with a bubble of very, very high humidity, and I could become a very unhappy plant if that humidity stays around the leaves, and I end up with fungus growth, which happened in another experiment. So the way we deal with that is we got to have fans to move the air around and mix it. The challenge with that is like, hey, just turn the fans on, it's great. But too much airflow can actually dry the plants out because of transport-evaporation. Getting the fertilizer right in microgravity is, we've been using controlled release fertilizer, but for long duration missions where, we're not going to pack controlled release fertilizer with us. So we would like to figure out how to use nutrient solutions and recycle those. And finally, lighting. Right now, we have plenty of solar power on space station. And so LEDs are very efficient. So we can illuminate the plants using the light emitting diodes. And the different wavelengths of the light emitting diodes are really a kind of a cool tool, so we can change the plan a little bit. So these are all things that we do on the ground and are more difficult in microgravity.
Yeah, so if we go to the next slide, we can characterize some of these as challenges that are specific for microgravity or deep space, low Earth orbit, the fluid behavior, lack of convection. Some that are specific for surfaces like the moon or Mars, dust and regolith, partial gravity. These ones in kind of the pinky peach, the radiation, the pressure, micrometeorites, those are all shared between those environments. If you look down in the bottom, those are challenges for any crops in any agricultural systems, how to be productive, how to grow with different stresses, how to optimize for your environment. And then those orange ones right in the middle are really kind of our unique challenges for growing crops in these environments. We have very little space, so we need small plants. We have high CO2. We have some kind of unique food safety and microbial issues because we're growing in the same place astronauts are living. And then we have to do all of this sustainably with some interesting stresses and limited resources. So we're really working to kind of tick away at understanding and responding to these challenges. So if you go to the next slide, this sort of talks about how we're doing this. On the International Space Station, we have two large plant capabilities. We have the veggie chambers, we actually have two of those, and we have the advanced plant habitat. And veggie is really simple, it's low power, low mass. Mostly astronauts do a lot of the work, or the space station, which controls the environment. APH, we call Veggie's big sister. It has over 180 sensors and controls all different aspects of the environment. So Veggie is more of a garden, and APH is more of a plant physiology research tool. And we're learning lessons from both of these that will feed into our future crop production system that we'll talk about a little bit more later. But we'll start with a little bit of history. So Trent, you want to talk about Veg 01?
Oh yeah, this was a joy. This was really fun. So way back in 2014, oh my gosh, 2014, yeah, 10 years ago. Yeah, we, Joy and I teamed up with the rest of the Veggie team, and we got this thing flown to space station. They installed it there. The top photo there is Steve Swanson, who was the commander. And half the plants lived, half the plants died. I think we had a germination issue, and then we had a drought. And Swanee was funny. He said he was batting 500. Needed to work on his green thumb. And the picture down on the bottom right is we did better on this one. I think we ended up having problem getting water into one of the pillows. But the other pillows that Chell and Scott Kelly there were able to water, they all germinated and grew. And so in 2016, we had the first flight dock approved. Red romaine lettuce, and they did cheers just like you do at home when you eat your lettuce. So it's the first steps to learning how to grow and eat our food in space.
Yep, so next slide shows when we added the second veggie, we did some mixed cropping. This is Scott Tingle, and he's showing off his mixed cropping with Mizuna mustard and then red and green lettuce. We had these slightly staggered, so we were starting to look at what a continuous crop production system would look like, how you could harvest every few days and eat over time. And this was based on the cut and come again approach that we first tested in Growing Beyond Earth year 1, and then tried out in space, which worked really well. And then if you go to the next slide, we tried other species. So we've done a number of different varieties, including the red Russian kale, the dragoon lettuce, the wasabi mustard, that one's quite hot, the extra dwarf pak choi, and then the Amara mustard. If we go clockwise, and if you click again, you'll see that those two were the Growing Beyond Earth student selected crops that came out of some of the earlier years of testing and then went to the space station. So
let's just make it clear. I'm sorry to interrupt, but I mean, this is important. Those crops, Joya and me, the rest of the science team, we didn't know about those. Those were first identified and tested by student citizen scientists, just like yourself and your students. And then they tested well. We saw it in the data, right? We saw it in the Google Docs. We were looking at the observations, and it looked like a good candidate. We tested it back at Kennedy Space Center, and then we flew seeds to space station, and they grew them and ate them. So I'm sorry to interrupt, Joya, but I can never overemphasize how important that is.
Yeah, and probably many of the people that are on here tonight who are returning. I mean, you guys were involved in doing this, and your students were, and we're just so grateful. So yeah, if we keep going, this was Veg 05. Veg 05 didn't go quite as well as expected. If you click again, you'll see these tomato plants just looked pretty gnarly, I guess would be a good term for them.
Gnarly's a good adjective for that
term. One. Yeah, they were not happy. We had a lot of water stress. We had some other issues with this one, but we learned a lot. We're analyzing the data now. We can keep going. We have some APH crop research. So this was the radishes. This was the PHO2 radish investigation, which led us to do radishes and Growing Beyond Earth. We started with this cultivar, the cherry bell, and we looked at a lot of other cultivars, and you and your students have come up with some other really good options. So we haven't had an opportunity to grow them yet, but they're on our list. The next one was the chili peppers, the Española improved hatch chili peppers, which flew in 2021. And, doing some work at home during the pandemic, Growing Beyond Earth helped to understand more about the biology of these pepper plants. So these were great. The astronauts got to eat them and really enjoyed them. And then next is upcoming. So launching they've just moved the launch to October 30th. We're hopeful, fingers crossed. We're going to be growing our favorite lettuce, Outrageous lettuce, in APH, looking at different substrate moisture levels. We really want to understand how chronic drought, chronic flood, and intermittent water and wilt impact the plant growth and the plant microbiome and the entire kind of ecosystem. What's the best way to design a system so that if it fails, it will have the least impact in the future? So we're going to really grow a lot of this lettuce. We're going to grow it for 3 times and try to understand all these different aspects of the biology. The astronauts aren't going to get to eat it, but we'll learn a lot, I think. So what else is next? Trent, you want to talk Ohalo?
You bet. So as Joy mentioned, Advanced Plant Habitat is an advanced physiology lab for plants. Veggie's a simple garden. And so the next generation is a continuous crop production system. And so this is being designed at Kennedy Space Center. And it's going to have the capability to recycle the atmosphere by condensing the moisture out of the air. And we'll keep reusing that water like Advanced Plant Habitat does. But we don't have 180 sensors like Advanced Plant Habitat does. So we're sort of trying to find the middle ground between the two systems. And the most important part is there are 2 teams working for different technologies to provide the roots, basically their rooting media. There is a group in Wisconsin called Sierra Space, and they're using a aeroponic and an ebb and flow type of system that will work in microgravity. And then there's a group at Utah State University that are looking to use a long fiber PEAT with sensors and water delivery. And so they're looking to interface with OHALO, and it's about 0.4 square meters area, and it's sort of short, a little shorter than our other units on space station. So we'll need some compact crops to grow in there. But the idea with this one is to dial in what it takes to continuously produce crops on the way to Mars. And so the things that we learn here are going to inform us on the design for the Mars Transit Vehicle.
Yeah, and then one last thing that's been really exciting, well, no, two last things. One last thing that's been really exciting was CHAPEA. So CHAPEA Mission 1, this is the crew from the CHAPEA Mission 1. They just completed their first year mission this July. So they were in there for 378 days. When I say in there, they were in a simulated Mars habitat. If we go to the next picture, you'll see them going inside. This is a habitat at Johnson Space Center. It's 3D printed, which is really cool. And they lived inside this habitat as if they were living on Mars with time delays, no direct communications. They had extravehicular activities where they had to put spacesuits on and go outside to do things. And outside was kind of a dome, a bubble, a Mars sandbox. They didn't get to see other people for 378 days. And we were fortunate enough to be part of CHAPEA. So if you go to the next slide, you can see the crops that were grown as part of CHAPEA. This was a photo the crew took on their 150th day in space, or on Mars, I should say. They had a really exceptional mission. You can read about or listen to some of their audio logs. They did a podcast called Houston, We Had a Podcast. They did Mars audio logs. But we got a ton of data from this mission. And if you go to the next slide, this shows the crew coming out. Didn't quite advance. There we go. When they were first back on Earth, out from their Mars habitat on July 6th. So you can see with their sunglasses, I think they were having quite a time adjusting to being back on Earth. But we are starting CHAPEA 2 next spring and summer. So they're doing the crew selection finalization for Mission 2 now, and we're really looking forward to learning more with that. We need to do multiple runs of this CHAPEA mission to get a large enough sample size to really understand statistically what's going on. And we'll talk more about statistics, I think, later on. But it's really important to do these types of missions. So yeah, I think we certainly could use some educators in there. Next slide. And then this is the last exciting thing. This is our LEAF experiment. So we are part of a team along with a number of universities. The team is being led by Space Labs Technologies, a small business out of Colorado. And this is to do a lunar plant experiment called LEAF, Lunar Effects on Agricultural Flora, where we're going to have model crops growing on the moon. So we're working really hard to get ready for this. And of course, Growing Beyond Earth is going to come along with us, and we're gonna keep you guys abreast of all of the exciting research that's going on in LEAF. So yeah, we're very excited. We are over the moon. So I think we can go to the last slide, and we are done.
Thanks, Joya. Thanks, Trent. Do you guys, I know you have you're on a timetable and you have to depart shortly, but do we want to have any Q&A for Joya and Trent before you guys have to leave? Does anyone, and you guys can feel free to unmute or catch our attention in chat. That was a beautiful overview and a lot of insider knowledge.
Yeah, sorry about the phone going off. Thought I had it muted.
That's okay. I didn't even hear it.
As a first year, I was just wondering, what's the next step after this?
The next step for you or for NASA?
Just for us as educators.
We're
Sure.
gonna learn all about that today, so that's
You-
what the next part of this is.
You will indeed. Yeah, we've got a whole rest of the training for that, and we will give a deep dive into that, and you can ask that question again when it comes up if we don't hit it.
Yeah, and we are excited. Every year we fold new NASA research into Growing Beyond Earth. So if you continue with the program, you'll have the option to, to do new investigations over time and, keep abreast with the active research that's going on at Kennedy Space Center.
Joya, there's a good question that I think if we're going to take one question, because I know we have to move on, we've got a lot, but there's one good question in there. If you had to choose, what do you think is the biggest challenges of growing plants in space, and what should the students be considering as they go forward?
Oh gosh, yeah, picking one is really hard because unfortunately there are some things like Trent talked about, the water and how watering is so hard that we can't really test on the ground. So I think the biggest challenge that Growing Beyond Earth can really help us with is advancing the crop readiness levels. And we should have put that graphic in here. I wasn't thinking, but we have crop readiness levels, basically identifying good candidate crops and then
I've got you, Joya.
Oh, there we go. Okay. Awesome. Thanks, Nathan.
You're
yeah,
welcome.
so these are our crop readiness levels where we're trying to, get the crops essentially ready for flight. And so, we depend on Growing Beyond Earth to help figure out which are good candidates, which are going to grow in a small space, which are going to be fast, which are going to be productive, which may grow well with others, which may respond well to things like our lighting or the radiation. So all of these questions help us come up with a portfolio of crops that we can use to feed the astronauts in the future. And, as you've seen, we haven't tested that many crops yet. So we have a lot of work cut out for us. We can only test so many at a time. And some of the things on here, you guys are probably not set up to do, like, the chemistry or the microbiology. But if you can get good candidates, then we can grow them at Kennedy Space Center and do those follow-up tests. So I think that's really where we need your help.
That's great.
And I just want to concur and just pile on. There are thousands and thousands of crops and cultivars, and the testing that you all perform help us understand what we want to grow in our environmental test at Kennedy Space Center. And when we look at the data, we can see what a robust crop might look like. And then when you test the different lighting, we can think about lighting that we might want to try with these crops. When you test fertilizer compositions, it informs us on different fertilizer ideas to go test. So all the things that you are doing in Growing Beyond Earth inform our science team, and we use the data. And I just can't emphasize that enough.
That's perfect. And this will come up again, but we have a new data portal which will help collate, organize, and make all of that data easier to work with for NASA and for really, essentially it's open source for you guys to compare with other schools, other teachers, other classrooms. So there's just a wealth of data that you all will be collecting. Okay, well, Joya, Trent, thank you. I think we're going to move on to the next phase.
Sounds good.
Okay, let me back the slideshow up. I saw a question in there about field trips. That's a little bit outside our scope for Growing Beyond Earth, but it's something we can talk about internally and see what we might be able to do with something like that.
I think they meant field trips to Kennedy Space Center.
That's right.
not us.
Yeah, exactly.
That's
So
not
that's
us.
not really within our scope.
Yeah, we may try to do some virtual tours again. I think we've done those in the past, and there are a few of those I still think online. Unfortunately, because we're a secure facility with the badging, it's a bit challenging. As much as we would love to have you
Okay.
all visit, it doesn't always work. So
Yeah. Okay, well, the next part of our training revolves around our program evaluation. So this is a partnership, a grant funded program through NASA, through the US federal government. So we have taken on an independent evaluator who looks at various aspects of our program. She will send out surveys to you all as you work your way through the program. In fact, there's one at the end of this training tonight to provide evidence that you have completed the program. But it's a way for us to see where we're doing well and any places where we can make improvements. So her name is Kavita Vitapala. She was not able to be here tonight, but she did make a video recording, her and her colleague. So I will play that. It's about a 7-minute video, and that will give an overview of just what I'm talking about. This. And I'm probably going to have to reshare screen. Anyone out there, did this catch the new video? Or do I need to reshare?
We see the video, but I don't know if we can hear it now.
Okay. Thank you, Amy. Let me see if I can fix that by resharing.
Hi, my name is Daniel Bernal, and I work with MN Associates.
How's that, everyone? Good.
Inc.
Good.
We are an evaluator, and we are working on the Growing Beyond Earth project evaluation. I'm going to tell you a little bit about that today. So since GBE is a federally funded grant, it does require an outside evaluator. So MN Associates serves that role in order to assess the fidelity and efficacy of the grant across all of the grant years. So in serving as an external evaluator, MNA has developed a robust evaluation plan that includes both formative and summative types of data. So formative meaning that will be providing feedback periodically to the GBE team so that they can use that to improve their program and take any corrective actions that they deem fit in order to make sure that the program is serving the needs of the participants and meeting the needs of the grant. But we will also be providing summative feedback. And so that will help to provide information on the outcome of the grant over all of the grant years, as well as the efficacy of the grant in terms of meeting those outcomes. When we talk about different data collection sources, there's a lot of different ones that we use. So we use a mixed method approach, including surveys and assessments that are taken by the participants themselves. But we also have things like focus groups and interviews that we do with participants to get a richer picture of some of the different experiences that the program participants are happening. That will also include application information, demographic information, so that we can see the picture of who is being served in these programs. The other sources are observations of the program, but then also a database. So making sure that the data is being collated and curated so that it is accessible and easily analyzed for the future as well. So some of the key metrics that we are using, as I mentioned, demographics. So name of the school, grade level of the participants or grade levels that the teachers teach, race and ethnicity, whether the students or teachers are coming from a new school, new to GBE, or whether they're returning. They've done the GBE experiments before. We also look at learning outcomes as it relates to different subject areas, knowledge, growth, as well as questions related to self-efficacy and STEM authenticity. And we're also looking at assessing educators' engagement and satisfaction with GBE. GBE really wants to make sure that this program not only does what it says it's doing for students, but that it's easy, relatively easy to use for educators and impactful for educators as well. So when we look at the actual outcomes that the program evaluation is built around, there's several. So the set of questions that the student survey includes was developed with the science mission Directorate, SMD, at NASA. And so we assess participants' interest in STEM and the development of their identities as science learners, interdisciplinary content related to NASA and engineering, participants' understanding of science using NASA SMD, the participation in learner-centered experiences based on NASA SMD, the diversity of participants, as well as the development of skills for STEM jobs and careers. A lot of different outcomes, and the data that is collected, several of them map to different ones, so we can see the same outcome in a few different lenses. One of the interesting metrics that is used is the SciAct metric. So this addresses that first question of science identity. And it asks students to identify with 1 through 7 these different images. So how do you see yourself as a STEM professional? And essentially it's saying basically, how much do you think you overlap with your identity with a STEM professional? Students get a chance to meet STEM professionals through the GBE experience in a variety of fields. And so the hope there is really that they're going to be able to relate to, identify themselves as interested or excited about, or as already engaging in STEM activities. And, you know, preliminarily, this is one where we've seen students increase from the beginning of the program, how much they identify what they have in common that overlap with STEM professionals. So it's a unique metric that is part of the data collection. In terms of the data collection timeline, we are really looking in the fall to look at the educator training surveys. So the trainings that you're participating in right now, these are, there will be a survey follow-up sent out, and that is very critical information that we'll take a look at to make sure that we're knowing all the demographics of participating schools and how helpful these trainings are in order to prepare you for the program. And then starting next year, there will be, in the next calendar year, there will be educator and student surveys, another training survey, then different surveys related to different events or opportunities that are part of the GBE program. So the Ask a Scientist event and the Symposium event has a post survey. And then there's also dashboards that are created periodically so that some of this data can be displayed, especially some of the data that's being collected in the actual experiment, so that students can really see and educators can really see the results of their work across the network of different schools that are working on this. And that in 2026, it's much the same. So those are some of the data collection things that happen year to year for this program evaluation. That's a very brief overview, and you're going to be learning a lot more about the program. But if you do have any follow-up questions, you can always reach out to us, MN Associates Inc. At www.mnassociatesinc.com, or reach out to Kavita, who is the leader of our organization, at kavita@mnassociatesinc.com. Thank you very much, and we're excited for you to participate in the program.
Okay. Just resharing screen in a different browser. Okay, so can everyone see spacecraft production? Looks good? All right, well, we're going to start moving into what this looks like in the classroom for you throughout the year. Before I keep plowing along, does anyone have any questions on the evaluation part of our program? What grant year is the funding currently on? We're in our 9th year. In fact, I don't know if Amy or Carl, you want to make a comment on our grant funding or what the future of that might be, but this is our 9th year and we've been fully funded all 9 years.
So the grant has been funded through funding from NASA since its inception, and we're working on continuing that funding for as long as we possibly can. So as long as we have funding, we can continue to give away the materials for free to the community and continue to run this program. So Carl, you wanted to add anything to that?
Well, yeah, maybe just a slightly more positive spin on all this.
Oh, I
We're
mean-
getting a lot of feedback from many people at NASA and other agencies and other places, other organizations that want to see the program grow, and not only grow but grow aggressively. So yeah, expect some new announcements pretty soon. But yeah, we're pretty excited about the future.
Thank you, Carl. I appreciate that.
Thanks, Carl and Amy. I see a question from Lisa. Are these evaluations considered as formal assessment and will be made to the public? Anything that's made, these are, that's okay. This data is not, if it's used in an academic way. It's no names are released. Its primary purpose is for our internal assessment, but this information, those kinds of charts that were in the presentation from M&N Associates, those could show up at an academic presentation, but no names of any teachers or students would be attached to any of that data.
Just so everyone knows, we have IRB, which is institutional review, that we can, you know, if we're planning on using and decide that we're going to publish some of this data, that we do some surveys that are qualitative as well as quantitative. Definitely we will have folks, filling out all of the necessary paperwork and things, but we will be publishing some of this eventually, but without names, without identifiable data, just general broad information.
Okay, let's push forward. So I'd say we're maybe about a third, maybe even a half of the way through the training. We'll see how things flow. But the next part up, I said, is how it looks in the classroom. So Brianna, if you're there and you want to, I'll advance some slides, but if you want to share your screen and give a little tour of the website, which is where all of the resources that you will be using through the school year can be found. I'm happy to do it, Brianna, if you.
Nope, that works with me.
Okay. Let's do this. I'm gonna talk a little bit about. I just want to make sure, because there's so many people on the screen that you were still there. But let me go through a few of these slides about the logistics, and then you can take them through the website resources.
All right, that works.
Sound good? Okay.
Yep.
Okay, so as we've mentioned, Growing Beyond Earth is a partnership between Fairchild Tropical Botanic Garden and NASA. This has been, as Joy and Trent talked about, in depth. But what you will receive in the classroom, if you're a new teacher, you will get a growth chamber modeled after the veggie plant growth chambers on the International Space Station. This is free for all new teachers. If you're a returning teacher, you have your chamber. You're welcome to, you can always purchase more. But for those returning teachers, keep in mind that you still get the free consumable pack, which we call the Science Resupply Kit. That's going to be your kit for whether you're doing irradiated seeds, novel crops, whatever experiment you're doing, you will get your growth media, fertilizer, seeds, pots, etc. And we'll talk about how that will be distributed. I encourage you, because I know that the school timeline, you want to get your experiments, you'll need to get them done really before Thanksgiving. So our timeline here is we do think the turnaround time for you to be able to get your equipment the week before October 1st, so that you're able to see what you've got, think about how you want to work it into your curriculum, introduce it to your students, and then start your experiment around October 1st would be ideal. That way, if you have one of the shorter experiments, the 28-day novel crops, you'll easily be done before Thanksgiving break. Even if you have one of the longer experiments, the 49-day trial, still you'll make it done by the week before Thanksgiving. And the reason we try to encourage you to be done before Thanksgiving is the plants need water, and we don't expect you guys to be coming in during Thanksgiving break and giving your precious plants the water that they need. So that's the first experiment. That's the one that we have designed for you. We call that the prescribed protocol. And that's one of the 4 experiments that we've developed over the summer. And then the second experiment is one that you will develop with your students and you'll run it by us and we'll give you some tips, see if it needs to be massaged in any way. And that's where you will run your own innovative novel experiment in the spring. And that leads into what we encourage all of you to do. We hope you can all, with your students, take part in the symposium in the spring. That's in April. We have an in-person venue right here at the Garden. That's for local schools, but sometimes schools from around the country are able to make the trip in. But we also have a Zoom component to that as well. And we have NASA judges. You'll see Joya and Trent there. You will see a variety of other NASA and university judges that are donating their time to give your students some really great and valuable feedback. Right, so that's just a cleaner overview of the flow of the year for you. And I just wanted to emphasize this is that you guys are extremely valuable. You are 1/3 of the partnership that exists for Growing Beyond Earth. So it's NASA, Fairchild Tropical Botanic Garden, and you and your students doing these experiments and providing the data back to NASA, that level 1, level 2 exploratory data that can then be built upon those roads traveled down further by other scientists. But things that we will be providing to you are on the right-hand side of this graphic. So as I said, we have developed protocols for you for this fall. We have the veggie chamber and all the consumables that we've picked out that are modeled after the NASA version of veggie, the actual veggie. We have a data sharing portal, which I alluded to. We'll take a look at that in more detail very shortly. Monthly chats with the scientist. This point here, the monthly newsletter, that's going to be our main way of communicating with you on a regular basis. So please do every month expect around the 10th to the 15th that you will get a newsletter from us. This month, September, it's going to be a little bit later. In this month, that newsletter, if you complete this training and you say, yes, I'm really interested in being part of Growing Beyond Earth, you'll get that newsletter, I'd say sometime next week. And that's going to include some information for you to get your equipment. Last thing to say about that, if you're finding by September, October, you're not hearing from us at all, check your spam folder, contact us, and we'll make sure that we actually have you on our newsletter application, your email address, because we don't want you to miss out on anything. We have teacher ambassadors. We might even have some out. Actually, I know there's some out in the crowd right now. I've seen you in chat. And I see your faces here. Teacher ambassadors. That's a great program that we're looking to develop further. Maybe make it an official NASA ambassador program. We'll see. We have curricular activities. That's one of the things that I was brought on to develop. And I've got Alex here that's going to be working with me on that. Brianna's going to work with me on that. But right now, we have just a handful of activities, about 4. We just got started with it. But my vision is that you guys will participate and start sharing activities with us. And we'll format them in a way that they're GBE formatted, but we hope to build up that reservoir of activities that can wrap around this experiment. Everything from students learning about plant physiology to learning about the physics of photons in a radiation. Okay, the last part is the annual symposium. I put that on here just as a reminder again that we really do hope you participate in that. It's a great opportunity for you and your students. That occurs in April every year. This slide I'm not going to go through in its entirety. This I just put up as an illustration that Growing Beyond Earth is constantly innovating, and we have many new changes that we are going to unveil for this year, and we'll be talking about them in the remainder of this training. Participating schools, we hope to get past the 500 teacher and school mark for this year, but schools all around the world participate. All right, Brianna, this is where I'm going to pass it over to you if you want to get set up with your screen share. We'll go to the Fairchild Garden website and get on the Growing Beyond Earth page.
All right, great. Can you guys hear me okay? Okay, perfect.
And Brianna, when you're done, feel free to pass back to me whenever it's ready.
Okay, great. So our website has gone through a few changes this year. But as participating teachers, what you guys are going to be using a lot is going to be the participating schools and the space plant teacher resources. Under these two, we have some announcements as well. So you can see we have our teacher training sessions. I did see some people asked if there would be slides and recordings of this session. Those are going to be right here on the September 10th dates. And so we'll go straight to the participating schools first. In the participating schools, you'll be able to see our timeline, as well as if you hover over the participating schools words up here, we'll have our links to the Shopify, data portal, and our QuickBase. Let me see. We'll also have a Q&A that will be filled out as the school year goes on. Yeah.
Can I interrupt for a quick? We don't
for sure.
see your screen. All we see is
Let
where
me
it says
try again.
website.
Oh no, let me try again.
Say that, Amy. Say that again, Amy. What is all
I
that?
can see it, Amy.
It was okay for me too.
Okay. All right. Got a couple of people.
But
there.
thanks. Yeah, I'm,
I
I'm
cannot
curious if
see
other
it.
people, if
None of
other
us
people
can
can't
see your
see it.
screen.
Okay.
Okay, let me try that one more time. Sorry about that. All right, can everyone see it now?
No.
I see some thumbs up. I see some nods.
I can see growing beyond Earth.
I can see it.
What is it supposed to show? Nathan, I think it's because you're still sharing your screen. So I think if you unshare, it's gonna just make it so Brianna can screens showing.
Okay.
So
Zoom is
kind of
getting-
interesting because I can see it just fine.
Now
see
it
it.
works.
She's showing.
Me too. Okay. Well, Zoom has its hidden anomalies, I suppose. But I stopped sharing, so I am out of the picture in terms of
All
my
right.
screen. It should be.
Can
We're
we
better
see it now?
Okay, I see some thumbs up there. Thanks, guys. Appreciate
Okay,
it.
perfect. All right, so
Brianna, would it be okay if you just quickly? I think it's
I'll
worth
back
it.
up.
It only
I'll
takes
back
us a
up.
couple minutes, and it's worth it for people to see because this is where they're going to be going to find information.
for sure,
Of course, you
for
guys
sure.
can always email us, but
Yes. So we'll go back to our homepage. Our homepage is going to have a little bit of a introduction, and then we'll have 3 tiles here. So the first one is interested schools, the second one's participating, and then our space plant biology teacher resources. Underneath that, we'll have our announcements down here. The 2 tiles that you guys will be using the most are going to be the participating schools and the space plant resources. Sorry. We'll go ahead into the participating schools first. So here, the first thing you're going to see is going to be a timeline for the school year, as well as right below it is a Q&A as we'll fill out as the school year progresses. When you hover over participating schools on our menu, we will also have 3 links. So we'll have our Shopify, data portal, and QuickBase. All 3 of these links we're going to go over a little later in the training session. Right next to that, you'll be able to see our research protocols. So here we'll have 5 links. Each one of these links directly to our protocols for each of the experiments. Let me see. And then the last big area that teachers are going to be using is going to be these teacher resources. Here will be quite a few resources, it'll also include our curricular resources as well. So 2 very important ones to kind of highlight right here is the training videos and training sessions. So the training sessions are going to have the recordings and slides here, as well as the announcements on the first page. And then right above that, we're going to have our training videos for our experiments and data portals linked right here. And I believe that is the majority of it. Have I missed
excellent.
anything, Nathan?
nope,
Right,
that was
perfect.
excellent. Thank you. Okay, I'm going to
Right.
reshare my screen, so you might want to stop sharing on yours. Okay, so you shall see my screen, which says data portal. I see some thumbs up there. Appreciate it. Thank you. So the data portal is new. In the past, for those returning teachers, you'll know that we had spreadsheets. This data portal is really nicely designed by one of our partners, but it's quite intuitive. We'll take you through a little bit of an overview of it, but as Brianna said, on our website, she has created, I believe it's 3, right, Brianna? 3 or 4 concise tutorials that are 2 to 3 minute long. That's really all you need to get in there and start putting in your data. Like I said, it's very intuitive. Your students will learn it quickly, but I will go to that in just a moment. Let me read some of these other points. So the data portal, the way to log in is that once we finish this training session, and at the end, you'll get a little survey. Do you want to be in the program? And you click yes, then we know you're on board and we'll start rolling the rest of it out. Next week, you will receive an email that will have several things in it. One of those things will be an access code to the data portal, and it will let you log in. And I'll show you what that looks like in just a moment. So let me get on that now. Some of this is making more sense to you. So when you go to the data portal, it's going to look like this. And I said it's very clean design, but one of the first things you're going to do when you're getting started is check your experiment. Based on the experiment that you selected, or if you're a new teacher, it's all novel crops for new teachers. Returning teachers can do novel crops too, but there's a radiate seed, there's a radishes versus light, there is the special media trial, but whatever one you have signed up for, we have already programmed that in, and you will see that as your only one in the drop-down menu. You'll get in there on your experiment, and you will see that your first page here is already set up to look like the 6 pots that you will have in your chamber. And I'll take you around to some of these things. I'm not going to spend too long in this site. Like I said, it's very intuitive, and training videos are pretty nice on this, quite nice. But if I click on pot position A1, you'll see that it will let me enter the data for that plant. So if it's the week that I've planted it, it's going to ask you very specific data. It's asking the same question for every school that goes in. This is what part of the strength of this portal is to make this data very uniform, easy to collate, and easy to work with. However number of seeds you planted into that particular pot, what substrate you're using, we'll get into that a little bit soon. And then it goes on, once you get to week 2, now you're getting into the other plant metrics, the measurement metrics, plant width, height, depth, number of leaves, and so on. And then you'll go along until you finally get to the harvest week, which if it's novel crops is the 4th week. If it's one of the other experiments, it's going to be the 7th week, but that will have many of the same metrics in that last week, number of leaves, the dimensions of the plant, but also the harvest mass, the root mass, and the stem and leaf mass. One of the great things is that you can add images quite easily. So you just click on new image. Students can use their phone to capture this QR code, or if they're on their computer, if you're on your computer, you can simply upload from the local tab versus clicking on device and QR code. A couple of other things to mention before I come off of this is that the measurement data is one piece. The environmental data is the second piece of this. So that is laid out the same way as the individual pots are. Week 1, what was the average chamber temperature through the week? What was the average humidity through the week? What's the average amount of water that you added through the week? And you continue on with that data until you get to the end. This does a nice little graph here for you. If you'd like to have your students get a preview of what the data looks like in a visual, you can do that. You can decide as a teacher whether you don't want them using that option, if you want them to graph it first and then check their work against what this can do. That's up to you. Observation notes you'll see in the protocol. I wrote some tips of how you can use these observation notes to add in some data that might be of interest to you, or that you might think be of interest to us. that we did not ask you in the prescribed variables.
Nathan, there's a question. Is it average or total water per week?
Great question. That's average daily water. So you get a feel, because there is, while this is a science experiment, in a way it's also a gardening exercise, as you are learning the art of taking care of your plants, how much water they need on a daily basis. But the scientific part is recording that, so someone coming in the next day knows, okay, or the next week, okay, we've been using 1,300 mLs a day, and that's doing well. I'm going to continue with 13 mLs a day. Or if the plants are looking a little dried out when you come in the morning and it's been 1,300 mLs, let's try 1,400 mLs today, or 1,500. So yes, that's a daily, an average of daily values. That's a really good question. Okay, I'm going to come off of the portal now. That's about it to say for that. Just make sure this is sharing the actual thing that I wanted to share. Okay, so our next portal, this portal is smaller and one that you will not use very often. The portal we just talked about, the data portal, you're going to be using that on a daily basis, potentially, and most definitely on a weekly basis. But this secondary portal, QuickBase, if you can see the clip of the screenshot on the right, it's going to allow you to enter some things through the school year, some pictures of science in action. So these are not pictures of your plants necessarily. This is pictures of your students doing the experiment. That's a nice thing to add up so that we can collect some photos of students learning and doing science. It will allow you to upload your trial 2 proposal. So around November, late November, December is when you're going to work with your students. They've already run the first experiment. Now you're designing your follow-up experiment. Well, when you have your idea of just your paragraph of this is what we're going to do, this is our independent variable, these are the dependent variables, this is what the variables we're going to control, you can give that back to us very nicely through this portal. The other thing you can do in the portal is upload your presentation. If you do, like I said, we encourage you, we really want you to, if you do plan to attend the presentation, the symposium in the spring. In terms of that, I can show you that portal. It's very streamlined. Like I said, it only has a few buttons on it, and you'll only visit it several times in the spring, or excuse me, in the fall, and maybe once in the spring. So let me get on that. Okay, so you're going to see a little bit more than what you will. It's going to be a little bit busier on my screen, but this is essentially, does everyone see QuickBase and 4 blue buttons? Yeah, it's exactly what that screenshot was on the slide. One thing I didn't mention, you will at some point need to upload a photo release for whatever students are allowed to have their photos taken. And that can very easily be done here. Everything is just clicking and saying. There's a little bit of a lag here on our side, but really straightforward. Enter your school. We'll have this programmed in. We'll have your data in there, what school. You just have to go in and pick who you are and then upload files. Does anyone have any questions on QuickBase or what its purpose is? And you guys can unmute if you want to ask any questions.
Nathan, they've been asking a lot of questions. We've been answering them directly on
Perfect.
chat. So instead of
Excellent.
unmuting, they could just put them into chat.
Thanks so much, Amy. Appreciate that. Okay, I live my life in multiple browsers, so this is why it takes me a minute to reshare everything. This is how I stay organized. But I'm going to go back to the main slideshow, and we're going along pretty well time-wise, guys. We're actually pretty close to done, so thank you. I don't want to click that share. Okay, so you should see Shopify store. Can I get any thumbs up there if you're with me? Perfect. Thanks, guys. So Shopify, this is our storefront. This is where you will go to put in your orders. And remember, this is grant covered. Most of the things you're going to be getting are free. If you're a new teacher, you're getting your starter kit, that's your chamber and all your consumables to plant your plants. If you're a returning teacher, you're going to get your consumables kit, your science resupply kit for free. You can also buy extra chambers on there. I'm going to take you to the Shopify store, but before I leave this slide, as I mentioned, I'm going to be emailing you guys next week. For those of you that I know that when you say you really want to participate in this program, you will get that email from me that's going to give you a couple of different codes. One's going to get you into the data portal. The other is going to take you onto Shopify and allow you to get your starter kit if you're a new teacher, or your science resupply kit if you're a returning teacher, for free. So let's take a look at that.
Nathan, can I just add
Yeah.
something really quick? Because there's a couple
Yeah,
of
please do.
comments in here.
Yeah.
So, just so you know, there are complete protocols. And we haven't really gone over those yet, but
That's right.
Nathan will go over the entire protocol. So there's a lot of confusion on what plants and how much water and all of that
Sure.
stuff. So we've
Yeah.
written complete protocols for each one of these experiments that explain all of the details that might seem confusing right now. These are scientific protocols. They've been written in partnership with the NASA scientists to make sure that we're answering some of these questions that you may have. Right now, it just seems kind of amorphous, but as we go through these protocols, you'll get a better understanding of exactly what your experiment entails. And if there are any questions after that, like how much water, or, how deep do I plant the seeds? All of that
That's
stuff
right.
should be explained very well in these protocols. So if you just hang on a couple of minutes, I'm
Absolutely.
sure you get all that.
Absolutely. And that's perfect, Amy, because I believe that's the next slide, is to go through those protocols. And all the protocols are very similar, besides the variable that's different between each. They're all very uniform. So we'll go through one together. We'll just do an overview of it, and you will see it's very straightforward, and all the information you need is right in that protocol. And we are always available. If there's something in there that you're not quite sure about, you can email us at gb@fairchildgarden.org. Okay, so you guys should see on my screen and on your screen something that says collections. Yep, thank you for the thumbs up. So there aren't too many different organizational tiles here, because we're not selling a lot of different things. We're providing you equipment for your experiments, but complete kits. If you're a new teacher, as I said, you are going to get a code that will take you'll get the website link. You're going to go right to the store, and you'll have a code, so that when you click on GBE starter kit, new teacher, click, it will say $0 for you. And it's going to look a little different. There's probably going to be a button that says complete transaction, and it will take you to the next screen where you'll fill out just confirm your shipping address. You'll hit submit, and then on the back end, our warehouse fulfillment center will get that equipment ready for you and ship it out to you. Depending on where you live in the US, it could be to you within a few weeks. It could take a week and a half, but it will get to you. If you're a returning teacher, you're going to want to be going into the science resupply kit area. Like I said, that code will be for one free kit. So whatever experiment you have, that code will be associated with it, and you'll just go in. It's like shopping on Amazon, anywhere, but it will say $0. It's not going to say $75. It will say $0 for you. Now this $75 is, well, maybe this is your 5th year in Growing Beyond Earth, and you want a lot of chambers. Well, you can go back to complete kits, and you can purchase a growth chamber for $425. Let's say you want 3 of those. Add that to your cart, and then you want to choose 3 science resupply kits, and you go in here and you just choose what you want and complete that transaction. The last tile, if you want to show off your love and your dedication to Growing Beyond Earth, you can get a little bit of swag here. So we have some shirts, we have patches, people love the patches, stickers, and some other things. This store is, you might find a link to it somewhere. It will be, I'm holding it to not really allow any orders or any fulfillment right now until we complete all the training sessions and we know that everyone who is ordering from it really is in the program and wants to be in it and is prepared to be in it. So by next week, as I said, you will get that email with the codes and everything. All these different pieces will come together and move along for you. Any questions on Shopify or what its purpose is? Okay, I'm going to move along then. I believe this is the protocol component. Getting a little tired, sorry. Okay, so 4 different experiments for this year. As I said, all new teachers are going to do novel crops. Returning teachers, some of you signed up for novel crops. And then the other 3 experiments are as listed here: irradiated seeds, special media, radishes versus light. Let's go into, we'll just do novel crops. We'll click on new teachers, since you guys that are returning teachers is obviously more familiar to you. This is what it looks like. So it's going to give you a little bit of what you can decide how you want to share this with your students, whether you want to have a discussion with them, have them read this and then discuss with the class what the point of this experiment is. Then we go on to, and as I said, every protocol is laid out this way. We go on to what's the research question. So for novel crops, it's a comparison between several different varieties of crops that we have selected and that we will randomize and send out to you. You're going to get 3 different kinds, and I'll scroll down and show you which of the ones that you may possibly get. But the research question is, which selected plant cultivars grow best under our simulated ISS conditions? So we've got some of our NASA scientists that are specifically interested in this line of research. And then we get into the research objective. So this ends with a hypothesis. As a teacher, you can decide how you want to roll this out for your students. If you want to have them discuss the experiment and what they think a proper hypothesis or a valid hypothesis might be, you can do that. You can just get right into it and share it with them. But for this one, as I said, this is a comparison study. You're just going to see which of the 3 cultivars grow best compared to each other and record the data in the data portal. So the cultivars for novel crops and the cultivars that we chose are a little bit different for each experiment. Some of them have a little bit of overlap. You might see, if you look at all of them, you might see red romaine lettuce on 2 of them because that's a known quantity. So I use that as a control group for a couple of the experiments. But for novel crops, we've got 2 varieties of beets. One is that you're going to grow primarily for the leaves. In the amount of time that you're given, 28 days, it's probably not going to grow much of a root beet, and it's not really, hasn't been bred to do that. The other beet is the opposite. It's going to grow more of a root component of the beet. We have a variety of spinach called Seaside. We have Nebuchon bunching onions. We've got a garnet red amaranth. And we've got red romaine lettuce, the outrageous variety. And under these, I encourage you guys with your students to give them some time to see why each of these plants is interesting, at least from our point of view, and why they're interesting to NASA and potentially interesting to you and your students. Okay, so as we go along, we get into the growth chamber, what you will be receiving. We have tutorials, which are linked. These video tutorials are very straightforward. Putting the chamber together. I've done it several times by myself when traveling on presentations, and it takes me about 10 minutes, 15 minutes. It's really straightforward. You can put a few students on the task, and they probably don't even need the instructions. They can just put it together. But if they want the instructions, they can read it, or they can just click on the video link and follow along. Going down, there are some things as a teacher in the classroom that we do not provide, but as a science teacher, or if you're a teacher of another subject, you can borrow from the science classrooms. But standard things like a ruler, graduated cylinder, you'll need a scale that can measure mass to 1/10 of a gram, and then some other common classroom items, scissors, disposable gloves are optional, but recommended. A class notebook that you guys can record the data in as a backup to the digital online portfolio. Forceps camera, phone camera is excellent and fine. Going on, all of our measurements are going to be in.
Please keep the science notebook. We gotta record those observations. That's really critical. That way, if the web goes down, you have a written record, and it's good training too for young scientists.
Appreciate that, Trent. Yeah, thanks for backing me up on that.
Yeah,
and yeah, absolutely. And you know what too is that it can sometimes, while there is an ease to having a pre-formatted table, or here's how to make a table that's already pre-formatted and the students just plug in the data. There is an actual knowledge level and a skill for a student to decide, how do I make a data table that actually shows the variables that I want to show in a way that can communicate to other people. So that's where the lab notebook is another way that it has a value.
And observations, right? If something
absolutely
if you see something odd, you make a note and then put that observation into the web system that's been developed. So the observations are really important, because sometimes things don't go quite right, or you'll see something that's interesting. So those observations are really important.
That's right.
Well, and the averages, right? You know, if you're doing average for temperature, humidity, water, you've got to take those data every day and then be able to average them to enter them into the data sheet. So
absolutely. And you guys will decide, the teachers in the classrooms, whether there's a delay and whether you can, maybe you just can't get on the data portal at a certain time, but your students have taken measurements. They can take them in the lab notebook, and then at some later date, later in the week, they or you can enter them into the data portal. It's best if they do it, although I know sometimes you're going to want to do it, but it allows for that time delay. The next thing up is the LED panel. So we've had it in some of the graphics here. This picture is a little bit of an older one, but that gives the idea that the energy source for your plants is the LED lighting panel at the top.
And Nathan, I would submit to you that the LED panels that they're getting nowadays are better than what we got on Space Station and Veggie.
I bet that's true. Yeah, no doubt. The LED panel, there's a lot of physics to look into here, and I linked some nice resources for you and your students to look into what some of the common terminology that you might hear in the scientific literature, just people talking about growing plants, whether it's in space or just on Earth, PAR, PPF, PPFD, and so on. But on the more practical side of students working with the growth chamber is there will be a fan. For you guys that have a backup on one thing, returning teachers, you guys already have your chambers with the LED panel that you can control with the knobs and decide what the lighting recipe is going to be. And it's going to be what's in the protocol here. So it's going to be a 10 setting on the red. These have no units. The units do correspond with actual physical values of light intensity, but there are no units in these numbers. So it's 10 on the red light dial, 0 on the green light dial, 30 on the blue light, and 115 on the white. That's uniform across all the experiments, with the exception of the radishes versus light experiment, which is going to have, because it's a lighting experiment, it's going to have a slightly different recipe, or a few different recipes actually that you're going to be assigned to, so we can collect multiple data points there. But for new teachers, you guys are going to be getting a microcontroller controlled LED panel. So it's a small computer, Raspberry Pi sized computer, that's going to already pre-programmed to set the LED panel with this ratio. So there's nothing that you have to set. We have done that on the back end. As you get going in the program, maybe in the spring or maybe next year, you'll want to play with the lighting recipe as one of your experiments, and we will show you how to do that, how to get into the Raspberry Pi. And that's another learning experience for your students, is to get in there and work with some Python coding. And Carl, I don't know if you're still there. but Carl's in a different country actually. Yeah, so it's okay, but we have different ways of programming it. Python, we might be using a different programming language as well, but that's just more enrichment for you guys and your students. Getting on here down, planting the seed. So now we're getting into the actual consumable equipment. So I go through, same idea. There's a tutorial on what is written here. So you can prefer whether you want you and your students to take a look at the video. And then if you want to follow up, I would always go with the videos are more generalized because I wanted them to be general enough that they were useful for all the experiments. So you're really going to want to read what's in the written protocol here to make sure you're doing exactly what you need to do for your experiment in terms of measurements. But I'll take you through materials. So I've told you here what you're going to want to get ready so there's no surprises. Your mixing bin, your growth media, and we'll talk a little bit about that in a moment. Perlite and vermiculite. You're going to have a watering tray. You're going to have a wicking mat. All these variety of materials. In fact, let me load this up because you guys that are new teachers, this is a value to you. So I'll just scroll in a little bit here.
Fertilizer. It's a fertilizer.
Scroll too far.
So it's recommended.
Are you guys seeing the video screen? Okay, so this is a picture of us. And this is one of the, it's worth saying it now. This is one of the new changes in terms of the components of the consumable kits this year. The Arcelite, as you guys read in the challenge descriptions when you were choosing which experiment you wanted to do, Arcelite's giving us a little bit of problem. Us and NASA is that pH is off and some of the mineral concentrations are not quite optimal for plants right now. So NASA has a little bit of a, KSC has a little bit of a better way to deal with it than we do on our scale. So we have gone with an alternative and we'll see how it goes. It may end up being, for our purposes, may end up being even better than Arcelite has been. It may be worse, but that's one of the things we're going to test this year. So you can see that you guys will get a bag that is a mixture of this brown vermiculite and this white perlite. These are both inorganic substances. They're mined up. Very light.
This mix will produce dust.
All right, so we're pouring it in the bin, ideally outside because the perlite kicks up a lot of dust. You're going to mix in fertilizer. So you're going to mass out 20 grams of fertilizer. You're going to get a little package of 40 grams of fertilizer. You're going to use half of it for your trial. The other half will be used in the spring. Then you're going to move on. You're going to put in the amount of water that I've stated in the protocol. If I recall, I think it's 1,300 mLs, but we can look back on that. Maybe it's 700. But you'll put in that amount of water, mix thoroughly, and then it's time to get the media in the pots. So you just get it in there, fill it up to the inner ridge. That leaves a little bit of room for you to put your seeds in. You're going to do 8 seeds for everyone's doing 8 seeds, no matter how big the seed is or how big the actual plant's going to end up being. The way it's just standardized. There will be, as we'll talk about in a few minutes, there will be a pruning or a culling phase where you are going to keep the biggest 3 plants that you have by about week 1 or 2 and just keep those 3 strong ones, and any other little ones that crop up, you're going to just, sadly, that's the end of their lives, but you're going to just take them away. But you're going to put in 8 seeds. You're going to cover them with a layer, very thin layer, 2 to 3 times the diameter of the seed, as it's written in the protocol, little thin layer of that same media. You're going to label your labeling stakes, so you know what date you planted your seeds, what the actual cultivar is, and then I'll go back to the protocol, but each cultivar has a specific GBE number, whether it's GBE number 1 for red romaine lettuce, outrageous variety, which was one of the first plant that we tested years ago, but that's our own internal way of tracking these things. We ask you to use a randomizer. Anyone out there ever used random.org? Really straightforward to use, but yeah, you can, it'll take you just a couple of minutes to get on that site and see how to use that. It's written in the protocol. It's explained in this video. So that's just going to randomize your pots. It's a good way to try to minimize environmental bias. And then that's about it. You put in your wicking mat. The wicking mat's purpose is to distribute the water. So I say this in the protocol and it might come up again in a couple of minutes, but we water from the bottom. We don't water the plants into the pots. This wicking mat allows a better distribution of the water to all the plants. Put in your pots, randomized according to how random.org told you to put them in that 3x2 matrix. Set them off with an initial amount of water. And that's about it. Then you put them in the growth chamber, and that's your day one. Let's go back to this. So planting the seeds, as I said, 8 seeds, that's just even distribution. So your students have an idea. Try not to let the seeds clump up. This is me just writing about the randomization and what it might look like for your experiment. 700 mLs of the initial watering volume. That's going to be the same for everyone. You guys, week to week, like I said, that's the art of gardening. You're going to have to decide how much your plants really need in terms of water. It's going to depend on the humidity in your chamber. We're going to try to get it to between 60 to 80% humidity. Your fan can be adjusted by the microcomputer, or if you're doing it manually, you guys, that's a little bit of fun for your students, is to try to get that humidity. And there's a humidity sensor that will come with your kit in that target 60 to 80%. Anything else I want to say for this? Data submission. We've talked about the data portal. So that's this segment of the protocol. Just gives you an overview. And again, there's, I link to the tutorials that we give on the data
Can
portal.
I interrupt real quick? There was a
Yeah, go
question
ahead.
here.
Please do.
So where it says, where you said that, so that's day 1, or is that
Yep.
day 0? Because in the past, when you plant it, that is day 0, not day 1.
Yeah, honestly, it won't really matter for our, you can put it in as, it's the way we have it set up is it's just week 1. So there's no way to really differentiate whether it's day 1 or day 2. You can label it as such. I would label it day 1 because the plants are going to start to grow on that day. So I would call that day 1.
Okay, because in years
Okay.
past, we call that day 0, but that's fine.
I don't think it,
Yeah, because we usually go with like days after planting, you know, when we go for the days, so, or days after initiation. So that's why we go for day 0,
And
because then, you know, you're sort of on the same day. Day 7 is 1 week, 14, 28, it's, you know, 4 weeks.
Okay. Yeah, those are really good points. For the data portal, if you're in the manual notebook, I can make a note here and I can put it into one of our newsletters. Yes, we can call the first day of planting day 0. Although when you go into the data portal, if you guys recall, it's not set up by days. It just says week 1, week 2, week 3, because you may be looking at your plants on a Thursday, which is day 5 for you. If I'm doing my math, I'm not doing my math right. Day 4 for you if you started on a Monday. But if somebody else is looking on a Friday, that's day 5 for them. You can add those notes in the observation section, add those little bits of notes in of what actual day it was. But on the grand scale, it's just going to record it as week 1 data, week 2 data, week 3 data, and so on. Thanks, guys, for bringing up the 0 day. I didn't know about that historically. Okay, so moving on, plant maintenance. This is the gardening part where you're going to just take care of your plants. Perlite and vermiculite are very airy, so you get a lot of, the plants will love it if you give them enough water, if you water them on a daily basis, because the airiness, the roots and the gas exchange, the roots will have plenty of space to take up oxygen and plenty of space to release CO2. Sorry, my Zoom is acting a little funny. But as I was saying, the perlite and vermiculite, plants will love it if you do water them on a daily basis. So that will be something that you will want to look into as an educator, is whether it's you're the one that's going to make sure that the plants are watered every day by the end of the day or at the beginning of the day, or that you have a cohort of students that you just know that you guys are the watering crew. You're going to make sure these plants get their water every day. On a 3-day weekend, long weekend, 4-day weekend, if there are any of those out there, you're going to give them an extra amount of water than you normally do. Whatever you give them for a 2-day weekend, give them twice as much. And I say that in the protocol. give them twice as much if it's a 4-day weekend. So going on. Plant maintenance. So we've recommended here day 14 is for most of the cultivars of plants, day 14 is where if they're going to grow, they've already started to come up. And you and your students are going to pick the 3 best, or if they're only 2, then there's no thinning or pruning to be culling to be done. But if there are more than 3, you're going to choose the biggest 3 and just get rid of the extra ones. And by get rid of, and I say this in the protocol, it's best if you just snip them with a pair of scissors rather than just pulling them out, because the roots may be intertwined with a nearby plant and it could disrupt and injure the plant that you want to keep. So it's best just to snip it off at the base of the stem, and the plant's just going to die without any photosynthesis. Okay, and then measuring your plants. So this is another big section. So again, we've included a tutorial on the different metrics that you're going to want to measure, and then it's in writing as well. But the main things, recall, are the dimensions of the plant week to week of each pot of plants. So each pot you're going to look at, these are my 3 plants. I'm in week 2. I've got 3 plants in there. I'm going to measure the height of each and average them. I'm going to measure the width of each. Everything is averages. You measure the width of each and average and put that in the data portal. Same with the depth, z-axis. When you get to harvest week, which is week 4 for novel crops, then you have a little bit of extra data you're going to take, because that's the end of these plants' lives. You're going to be taking them out of the pots. You're going to be rinsing them off a little bit. That's in the tutorial, how to rinse them off gently just to get any of that growth media off of them, so that you really are, and drying them, patting them dry gently, snipping them where the roots and the stems and leaves converge, and then measure your stem and leaf mass and your root mass. And then wrapping up. So we've given you guys a daily checklist, which is just a summary of the things that you and your students want to keep an eye on day to day, and then a weekly checklist. I did go over photos. We encourage you guys to take photos of your plants as they're growing. I did mention that in the data portal, there's a nice way where you can easily add in images. And we've added something this year. You guys that are new, you won't know, but for returning teachers, this is going to be a little new for you. But we do have, I linked it here. I just have to find the link. We added in something that, like a photo image card. But it's going to be it's a way that botanists standardize the lighting and the various colors that can be coming from the lighting that the plant is under. Standardizes, helps compare measurements, so you can see the ruler on this photo image card. So you can lean it up there and have that in every picture that you take of a plant, along with the tag for the plant, so you know and anyone else knows what cultivar of plant that is.
Nathan, there's a quick something somebody suggested back to the humidity. It says, I would comment to new teachers that controlling or accounting for air humidity, the school air is likely way lower than experimental protocols. I always just noted that, and making sure that you're noting that in your notes. So
absolutely.
Heath.
Absolutely. Thanks, Amy, and thanks for that question. And I wrote that in the protocol that you might not achieve that greenhouse ideal of 60–80%. That's fine. As Amy said, you just want to, that's where the scientist part of it comes in. You're just going to record what humidity you were able to achieve daily and then average that on a weekly basis.
Yeah, and can I just say that's actually really important.
That data is important.
Yeah.
Because we might want to know, right, Joya, if a plant grows at 30% at an arid humidity.
Exactly. And on the space station, the humidity is only like 40% most of the time, and sometimes even lower. And so when we start to look at all of the data, we can get a survey across a range of humidity. So if your school's a lot higher, a lot lower, you know, then we'll start to get a feel, wow, these plants do really well in this range of humidity. So it's exciting data.
That's right. And thanks, Joy, for saying that, because there really is no bad data, right? If you've done your observations carefully, all this data is useful. Okay, and that's about it. And then I just remind you again about the symposium, that this is what this leads into, is that you're going to design with your students a follow-up experiment in the spring, and then potentially join us for the student symposium.
And
I got a question
can I
in
just
the
say
chat.
something?
Oh,
Yeah.
sorry.
I was just going to say something about the symposium. If you propose original research and you run the original research and you present your original research, you, for that time period, are the world leading expert on that data set, because no one knows it.
That's right. I
And,
love that way of saying it.
And you can teach the NASA scientist something that we don't know. And this is really, really incredibly powerful, because I think last time I remember I was sitting next to Dr. Luke Fountain, and he was scribbling furiously in his notebook as some of the students were talking, because they were teaching him something he didn't know. So
yeah,
I would just offer, if you get a chance, please do it. It is really important, and we learn right along with you.
Yeah, can I just also add, thank you, Trent. I think that's really important. So this is Amy again. The symposium is designed so that students get an opportunity to communicate their science, and learning how to communicate your science is valuable and important. And, you know, your science is only as good as you can communicate it. And so giving these kids an opportunity to create their own original research. So trial 1, we said, was prescribed research. Trial 2 is an opportunity for them to create some original research, test it, and then be able to present that, because NASA, the scientists, Trent and Joya, have used some of this data in some of these experiments, in order to move their research forward. So they're looking to you, to your students, for more ideas on how to do their research. Additionally, some of those original research ideas become experiments that we do in future years to test with Growing Beyond Earth for future NASA research. So the symposium is a really important component. So the virtual symposium is a day-long opportunity where your students get to spend 7 minutes talking to NASA scientists, educators, administrators, and share this amazing work that they've spent time and energy in doing, and that they're contributing to the NASA research. So as much as I can't even imagine what all of you, and like having 170, you know, teams presenting their research feels like, or 300 teams, I encourage you. We will make it work. We will figure out how to do it, but definitely an opportunity that I don't think, if you have an opportunity to do it, you should absolutely take it up on it.
That's great. Thank you, Amy.
And I just wanted to comment, there's a lot of good discussion or comments in the chat. And I just want to reemphasize what Joya said, that the recording the data, if you can't get the recommended relative humidity and the plant still does well, that's important data. There is, as Nathan said, there's no bad data. So these plants, you're teaching us what these plants can do, and growing plants in Colorado at reduced pressure and maybe low humidity, in Puerto Rico where it's sea level, right? That's a full 1 atmosphere and humidity. Maybe there's variations with your temperature. Maybe on the weekends, the AC gets turned off, or maybe the heat gets turned off, right? So these plants are dealing with perturbations, and I talk about these as perturbations to their environment. And you know, when you're growing plants for space travel, you don't want some finicky plant that's going to wilt and die if it goes, you know, drops 1 degree, right? We want robust, tough plants. And so your data sets help inform us what a robust plant can be, right? So this is recording the data, your observations. It really helps us understand what the plant can do. So I just want to mention that. So don't stress out about humidity, but record it. It's super important.
Appreciate that.
And can I add one more thing, Nathan?
Yeah,
So,
please do.
So Nathan had mentioned earlier that there is a live symposium that goes on here at Fairchild, and that's really just for the locals. That has been for the local schools. Some schools are able to come here. The virtual symposium, last year we had about 80 or 90 teams. The in-person was about 16. Eventually, we would love to be able to raise enough funds to be able to have people join us here at Fairchild for scholarships. Somebody asked us that question. So yeah, so we're thinking about that. I think that would be amazing to have a full, symposium at the garden. But at this point, the virtual symposium is the best way to get your kids an opportunity to present. It's, and really it's so dynamic to sit and listen to schools from all over the world presenting their research. It's pretty awe-inspiring opportunity for all of us.
Yeah, I would just echo that and also encourage them to, stay for other students' presentations. Like some people would just show up for their own and leave, but you really get more out of hearing what other schools are doing and just seeing how they present as well. It's a wonderful learning experience for everybody.
And one of the questions on here was the photo imaging card. I think, is that what
Yep.
you were going to answer?
So
Okay.
that's this. Yeah, I don't know that little card has an official name. Amy, can you remind me who's the scientist, the lab
Dr. Richard Barker.
Barker, yeah. I
created
don't even
this.
know if he had a name for it, but we're just calling it photo image card. I think he had a more a different name for it, but we're calling it photo image card. But it's essentially, as I said, it's a way for botanists to get a more standardized view of lighting and parallax, the angle that the camera is at, the actual objective dimensions of the plant, because there's a ruler on the card. So Lisa, if you're there and you're hearing me, that little photo image card you can see leaned up against the pot of the plant, that's going to come in your science resupply kits for this year.
Okay, great.
Yeah. And I think so that's the end of the protocol. And I'm going to go back to the presentation. And we're almost there. So this is the last component. If you've made it this far through, you have almost completed the training. The last part is to complete a fairly short survey. It'll probably take you about 10 minutes, but it's going to ask you some various questions. This is the evaluator wrote these questions, our NASA grant evaluator, and there's a couple of questions in there that are specifically relevant to moving forward. There's a simple question that says, I plan on participating in GBE this year. Yes, you've come to the end here and yes, I'm on board. No, you definitely, you sat through and you just realize you don't have the time, or there's some other constraint, you just can't do it. Or maybe that's valid. Maybe you say maybe and you're not sure, but definitely you say yes. Then we know early next week, we're going to put together all of your names of the yes people that you've completed the training, and we'll get these various codes out to you to get onto Shopify, get your equipment coming to you, get your data portal login, and move along to the next step. Okay, so if you have the link, I'm going to put the link back into the chat for the survey.
Link is already in the chat.
Awesome, thanks, Brianna. So we do ask that you please complete this here. This wraps you up for the training. When you guys do submit that, we want you to know that we thank you all for your time, because we know it's after work for a lot of you, for all of you.
Thank you, everyone. If you have questions, don't forget the email to reach out to all of us is gbe@fairchildgarden.org. I think it's probably in the chat somewhere, but I think we can put it back in there.
Yep. Thanks, Brianna.
I'm sure you'll have questions. We encourage you to reach out to us. Make some FAQs. The PowerPoint will be available, Nathan?
Yep, we're going to get this up on the website along with this video within the next couple of days.
Also, if I can just say to all of you, is just please bear with us. You know, with this new system, we have a whole new group of interesting issues that arise. So please just bear with us. We will make sure that you get all of your materials and equipment that you need within a timely manner. So just
I have a quick question if we're towards the
Yeah,
end. I
go
could
for it,
type
yeah.
it all out, but
No,
is there
say
a
it,
way
say it.
that we could have a contact if someone is doing the same experience close to us, like maybe we
Yes.
could you know, I could, and they've done it before, I could call that teacher and say, hey, I have this question and you're local. What did you do?
Yes. In fact, the data portal, I'm going to go back to that. There's a map on the front screen. I didn't go on it, but I'm going to take you to it right now. There's a map where you can see various schools and what experiments they're doing. And you can compare their data to theirs. Now, if you want to get in contact with an actual teacher, we can put a list together of teachers that are willing to have their email shared, and we can have a spreadsheet that says what experiment they're working on. And you guys can behind the scenes talk to each other about whatever things you want to talk about in terms of growing beyond Earth. So let me show you that data portal again. So you can see there's a map. There's not too many things on it right now because there's only the fake, it's not really fake, but it's us over the summer doing the experiments that led to the protocols that you guys have this year. But if I click on this 4, just keep clicking in on these dots. It will show me, so this is the different experiments that my summer interns are working on, and you can download the data. But what you're asking, maybe you don't want all this information, but maybe at some point you do want to have all this information and download their actual data and do some statistics with it, or just some broader comparisons. But we'll over the next few weeks, let's say, we'll compile a list that can be in one of the announcements in the letter. We'll create an editable spreadsheet, and we'll decide as a community. I'm going to ask you guys what you think the best way is of sharing your email. Maybe it's just making a spreadsheet that's editable by everyone, and you can just add your email there, put in the experiment you're working on.
Yeah, Nathan, it was pointed out in the chat too that we have the Growing Beyond Earth ambassador teachers, and
Yes.
so we should definitely have a way for new teachers to contact the ambassadors.
Absolutely.
Sure we'll have that.
Yeah, if you're an ambassador that's out there, can you just put your name in chat and then just say ambassador?
Yeah, we'll
That way we
probably
can see some
have to
names of
have
people.
a link somewhere. So yeah, maybe that can be in a newsletter too.
Absolutely. Yeah, thank you for that, Joya. That's a good idea. Is our Facebook group. We do have a social media site that we are putting together. It's going to be Instagram. Brianna, right? Are you still with us? Sorry to call you out. You may not be there anymore.
Yeah, I'm here.
Okay.
Yes, our
Okay. We're going with
our-
Instagram.
yeah.
Yeah.
We'll also be on YouTube as well.
Yep.
With all of our trainings.
Yep. So all of this, all these videos that we have, including chats with the scientists and so on, there's a YouTube portal where all of this goes. In terms of a Facebook group, though, we don't have that. Even our Instagram is going to be a little bit curated for right now, where we are taking some interesting results, maybe pictures in action that you submit on that one data portal, QuickBase, or some of your preliminary results. We may put up as a highlight of this teacher and their students in their school on Instagram. That may become something where we open that up for teachers to communicate and share their own things, but we'll see down the road how that plays out. That involves a lot of curation, and that might just be out of our scope. We've tried it before with Twitter. I think, Carl, I can't believe, Carl, you're still holding on. I don't know how many hours our CEO director has been up, but you're still with us.
Yep, still with us.
Yeah, yeah, thanks.
Sounds
But
right.
Carl, we tried, it was Twitter in the past, right? And it was good
Yep,
to
yep,
an extent,
and
but
no,
got a
so
little bit out of control. Maybe we just
yeah,
couldn't
so I think
curate it all.
having the quick base will be just a great way to keep in touch and see what's going on in your classrooms and everything. A lot less chaos than the world of X right now.
Right. Becky says, I'd love to hear more about how teachers close this out after all data has been submitted. So Becky, if you're on audio there, do you mean, so you'll submit all of your first experimental data by the end of the first semester. So probably before Thanksgiving, you'll have all that data in, and then you're going to run your own designed experiment with your students in the spring. You're going to put all that data in the portal too. And that's a little bit of ways away. And I didn't show you how to create your own experiment in the data portal. We'll put out a video. It's really, once you play with the portal for a semester, you'll probably figure out how to do it, but we'll send out a quick training video on how you're going to create your own experiment. Then you'll put all that data in the portal the same way you did the first experiment. And then you decide whether you want to attend the student symposium. And that's basically closing out. That symposium is the formal closeout of the school year for Growing Beyond Earth.
I meant a little bit more.
Sure.
Just meant a little bit more like kind of closing out that segment of saying, okay, now that we have this, like, I guess looking at some of the previous data so students can learn a little bit more about more in depth about how the data is used, things like that. So I just wondered if there was some structure around that other teachers have done to share, rather than just looking at the.
Right. So it's a good question, Becky. I still think maybe my understanding of it is that structure of what you are providing would go into a presentation for the symposium as a way for that data that you've collected to be presented in a formal way. Maybe I'm still not answering your question. And
no, I think
with our chats
that
with
makes
this,
sense.
I'm sorry to cut you off. Go ahead. I just didn't see your fit.
Yeah, I think I'll just dig into it a little bit more, but that makes sense. Last year we just didn't get to do the symposium. It doesn't kind of fit into the structure of our course. And so I was just looking for other ways of kind of closing things out and saying,
absolutely.
Here's how you have contributed. Here's the awesomeness that you've.
I've got you. I've got one other big way that we do it. We have our chats with the scientists that occur throughout the school year, and toward the end of toward that second semester, when you guys have collected some data, we would love it if you could join a chat with a scientist, even with some students. That would be a lot of fun for them, and they could get some feedback on their experiment and what relevance it might have for different scientists at NASA.
Great, thank you.
Yeah, and I would I'd like to just add that sort of comment, that sort of question is very helpful to us. Whatever gaps you feel might exist in the program, or gosh, I wish there were a way to wrap this up, or anything like that, or activities for the classroom, just let us know. We're not going to promise that we'll fill all of those gaps right away, but it's good to know what you would like us to provide.
Thanks, Carl. That's right. Brianna, Alex, you guys, thank you. I've got it from here. You're just staying there, Brianna. You're gonna just stay with me. That's fine. Alex, you're good. You've done it. You don't have to stick around. Yeah, I know you guys have. You guys are multitasking with classes and everything else, so it's okay.
So teachers are good to go, right, Nathan? If no one has more questions?
Yeah, if you guys have filled out that survey and you all of your questions are answered as of right now, yeah, Joya, thank you. You guys are free to go. Thanks again for coming to this training. We're really looking forward to an exciting year with you guys and your data and your students' participation.
I have probably a question that nobody else is interested in.
Yeah, Jose, go ahead.
Yes, so here's the deal. I do not teach directly with the students. I do not teach science. I'm a coordinator for technology curriculum in my school. And it has been my initiative this year to bring the program to the school, which I barely knew from, I don't know, 7 years ago in a Florida Science Teachers Fair or something, right? I am currently building a greenhouse. We bought a farm boat, but we have not put together, right? And I just wanted to bind all these with the program and just to make a more robust science program in the school that I'm working for, right?
Yeah.
So because this was my initiative, I decided, I'm going to be the one that is going to just move forward, do all these trainings, get ready, and then pass the information to the teachers, right? So I see that we have been like taking notes and recording the session, and then at some point at the beginning of the meeting, you mentioned that all these could be downloaded at the Fairchild Garden website. Can I just have that link so I can present this to the teachers and also just try to pass as much information as I can? So hear me out. I was here with my 2 daughters at the same time, trying to cook food and then just, like just being present as well.
Yeah, I get it.
So I would definitely need like a rewatch and probably those notes and all that, like
absolutely
as soon as possible. So, okay, so that's the link.
So you'll see the link. It's going to take us, give us a couple days to get that video processed and into our Google Drive and then putting the link, but we will get it up there within the next day or two.
Okay, so
and
now
the presentation, Jose, that's a much quicker thing. And I put that link in, but I'll put that in again of just the slideshow.
Okay.
But we will get the video of this session up within the next day or before the weekend.
Okay,
for sure.
So can I somehow enroll the teachers, or they will be behind me for you guys? How would that work?
The way it would work is that you're going to be the lead contact. So you're the one that's gone through the training. So we would want you essentially supervise. If it's other teachers and other classes working on it, that's great. We encourage that, but we would call you the supervisor of that program, and you're the one that knows the in and outs and how to connect. If you're not sure how to do something, you can get in touch with us, or that teacher can get in touch with us.
Okay. I just wanted to make sure that that's totally allowed and
totally allowed, and we have people that are in that same scenario and that have been doing this for years that do that. Absolutely.
All right. Well, that clarifies a lot, and then I'll be just really eager to have the recordings so I can actually pass it along and just rewatch it
for sure.
2 hours available. Thank you so much. No, that's good. That's good. I just needed the time to just get to
focus on it. Yeah.
Exactly. Thank you so much.
Thanks a lot, Jose. Take care.
Have a good one, guys.
You too.
I think I'm going to drop off, but thanks everybody. It's been
a lot,
really
Joya.
Fun evening, and look forward to the next kickoff on Saturday.
Yes.
Thank you, Joya.
Thanks.
Bye.